everyone. Today we have our another new episode and we will discuss on 3D printer for housing crisis. We have our world famous speaker, Professor Rob Enderle. What you want to discuss? I know that previously we attended with the concept of 3D printer printed house and that was very popular. So what's new? What about the new? And you know that World Talent Economy Forum, we are trying to solve the housing projects. So what we can do?
Well, 3D printed homes have a number of advantages. One of the biggest is it typically takes anywhere from 24 to 48 hours to build a house using 3 people. Where if you're building a more traditional home with regard to structures, you're talking month to 2 months, a much larger team, typically 20, 25 people to build the structure. So it's less labor intensive. It builds much more quickly. The process tends to use a cement mix, often adding other substances like hemp to create a greater resiliency and a higher insulating value in the cement, because cement does transfer heat relatively well. It's not a good insulator. And so adding to the mix a material that allows it to insulate, particularly if you're building in a colder climate or a warmer climate, is important. Now, some of the downsides, and we certainly have seen this in some of the problems that Turkey has had, is often in an emerging economy, people cut corners, and they'll use concrete that has too much sand in it because it's cheaper, and then in an earthquake or a weather event, the structure fails. That same thing could happen with 3D printing. So there would have to be a lot of focus on making sure that the material mix wasn't compromised, that somebody wasn't putting in cheap material, so the houses were going up but they wouldn't stand. But in terms of speed of building, 3D printed houses can go up very quickly, particularly if you're putting up a lot of houses that are virtually identical. And that's often the case if you're building out an area that's to take in a lot of people that have been unhomed, that have lost their homes either because of war or climate activity, and you need to get them into shelter. They're certainly much more, even in their weakest form, they'd be much more secure than tents, which is often what we put up for those folks. And tents, of course, not insulated at all. A lot of wind movement, structurally not very solid, and very vulnerable to things like wind. And often these big tent cities that go up there, people are being asked to stay in them for years, and really not designed for that. Their tent cities are supposed to be something that lasts for weeks and months, not years. And so 3D printed homes can come in and solve a problem and make that solution much more long-lasting than using tents. Now, another alternative is manufactured homes, and manufactured homes can also go up very quickly. They tend to be built in factories, and they're shipped to the site, and then they're assembled on site. Those work if you've got the manufacturing facilities to build them. So, for instance, in a place like Ukraine, where the manufacturing facilities would likely become a target for Russian missiles, probably wouldn't be a good place to do manufactured homes, because the Russians would go out of their way to destroy the manufacturing facilities, and you lose the capability. But in other areas that are not in conflict, where the manufacturing facility could be protected, manufactured homes might be an interesting alternative. If they're built properly, they too can survive, and in some ways survive certain kinds of events like earthquakes better. The concrete tends to be fairly rigid, and a manufactured home will sway with the earthquake and survive. A downside would be in a wind event. Hurricanes, typhoons, and tornadoes tend to create high wind, and they're a manufactured home, unless it's manufactured to survive those wind events, could be exposed, where a concrete facility tends to be much more wind resistant. Both methods work reasonably well with regard to flooding, depending on how you build them. Obviously, with flooding, you want to build up. Manufactured homes can be put on stilts, and 3D printed homes can be built multi-storied, and then you live on the second story and have a garage or whatever on the first story, and then the facility, the house will survive the flood. The thing I always like to point out when we talk about stuff like this is the old 1954 Disney House of the Future, which was built out of fiberglass and would fit within the construct or the envelope of a manufactured home. And the reason I bring it up is because that home was comparatively at the time easy to build, but I was there when they tried to tear it down, and the wrecking ball that hit the house bounced and almost went through a completely different building. They ended up having to cut the house apart because it was so robust, and they built it up so it would have survived a flood. It was earthquake safe, so it was specifically designed to survive the kind of weather disasters that we're currently experiencing, and yet the methodologies that were used, largely backed by Monsanto, never really left that prototype phase, and it might be something we want to revisit. Another underlying concept that might be worth visiting is something called narcology. Narcology is where you build a large structure and you house both the businesses and the homes in the same structure and make it self-sustaining. In the current construct, you would put in vertical farms. In other words, you would create it, you would put in solar, you put in wind. And once the building was built, a very large building, it would be self-sustaining. That much of the produce would be created in the building. The power would be generated in the building either through solar, wind, battery backup, or through one of the new micro nuclear plants that could be put in place. You could also put in a more traditional generating plant as well. But the end result would be something that could be better protected. And here we're talking about now, if you're not sure if you're going to have a weather event, a military event, or an earthquake, you could design across all of those and protect logistics at the same time you're doing everything else. Because as we've seen with these weather events, often the big problem isn't so much that people have lost their homes, it's they now have no access to power, they have no access to water, they have no access to food. And so an ecology can be built up to solve those problems as well, to assure the logistics of keeping the people alive in the construct. And you could 3D print an arcology that just would be an arcology at scale. So nothing says it'd be a little harder to do one pre-manufactured, but you could also do that. A lot of times when you're building a skyscraper, you will build a skyscraper in components in factories and then ship those components to the site and then assemble them. I was watching one of the big fabs in Israel go up that way. Many of the major components had been pre-assembled, and then they were built out kind of like you would build a Lego or a puzzle or a large scale model. And that can work as well. It really kind of depends on the dynamics of the area and whether it would be better to construct at the location or construct remotely. Because even with 3D printing, if you're having a lot of rain, a lot of snow, it's going to be hard to get that printer to work properly. It's best used when during a period of time when you're not having a weather event. Where with a pre-constructed or a constructed in part facility, rain, weather doesn't necessarily. I mean, it's hard on the workers, but you can still construct it and keep the water. Have a better chance of keeping the water out of the structure, since each one of the components can itself be somewhat shielded from the weather. So it depends on really the problem you're trying to solve, the capabilities that you have in country to solve the problem, and what kind of an environment you're constructing the facility in. And finally, what problem eventually you want to make sure, both existing and future problem, that you need to address. Because I think what we're seeing, particularly in Turkey and other areas that have been hit by earthquakes recently, people have not built for the future. They have built for the moment, with cost being the driving factor. And then when an earthquake came through, we saw the structures completely destroyed as a result. And here is a case where undoubtedly governments need to do a better job of certifying the buildings that are going up and requiring by law that they meet certain standards, regardless of the methodology that's being used, so the buildings survive these anticipated events, and we don't have events like we're seeing in Turkey, which are just horrible. And I'll stop there and pass over to Viva.
Thank you, Madam Viva. What you want to discuss about 3D printer for housing crisis?
I think it's really good that the 3D printing technology and also the modular tiny homes are included as well too. I think Rob gave a really good overview of the different types of housing, including the mobile homes. They are, vulnerable. These are going into vulnerable areas, so the infrastructure is really difficult to harden. Between the building itself and the services, the living housing services, that is, sorry about that, I have somebody trying to call me, just a sec.
Well, fill the dead air here. The tiny homes are actually an interesting concept because you can will them in place and immediately provide a place for somebody to stay. And Viva, as you pointed out, the issue often is with mobile homes, which aren't entire. I mean, they fall underneath the broad category of manufactured homes. But manufactured homes don't necessarily have to be mobile. But if you do use a tiny home or something like that, one, it's got to be heavily structured, and the other is probably needs to be locked down onto a foundation, so the high winds don't cause it to go to Oz. I'll let you.
Yeah, sure, Rob. Currently, the mobile homes are typically strapped down with cable to, a cement ballast of some kind or a cement pad. So, in Canada, that's how it's done now. For these vulnerable areas, getting the concrete in there is, a basic issue that I think is really not addressed. And it does make a big difference when you do strap it down with cable. There's no doubt about it. So that would be one thing that an innovator could come up with, is how to get an equivalent cement cable down system that can be brought into these places to secure the housing better than what it is. I think the infrastructure too, the sewage, water, and power, that whole system needs to be hardened more than it is already. I haven't looked into what they're currently doing, but, we see these tent cities where people are still using outhouses, or they're just transitioning over to portable toilets. And there's lots of innovation under Bill Gates, surprisingly, about the toilet. That is very important for these temporary and vulnerable areas that are taking on housing people. And, it would be great if we could find a way to get more people transitioned over onto, just basic modern toilets. That's all I have at this point.
Thank you. Mr. Rob.
Yeah, and Bill Gates is a good example. I know Bill. He a long time ago, he back in the 90s, he went on a tour and to Africa, and the folks were talking about opening Africa up to technology as a market, and he sat back and said, this isn't going to work. These people don't have medicine, they don't have food, they don't have clean water. Until those problems are solved, they're not going to be buying PCs and smartphones. And of course, kind of wrong about the smartphone thing, but they're not going to be buying a whole lot of tech if they can't eat. So he uniquely is he left Microsoft for a number of reasons apparently, and focused on really trying to solve some of these problems. But the good point on really thinking through the long-term implications of sewage disposal, sewage and waste disposal. We've certainly seen a problem with military establishments and burn pits, which are often also used in areas where you've got tent cities, because how else do you get rid of the waste? And the problem, of course, with burn pits is they're highly carcinogenous, and so you create a problem, a huge pollution problem for not only the tent city or the temporary dwellings, but for everybody in the vicinity. That sewage can find its way into groundwater, and now suddenly your wells are contaminated. That was a huge problem. I was involved in a project in Africa, where the tribes were having a massive problem with regard to clean water because they were consistently contaminating their wells, and sickness was running rampant as a result. And so technology did come in and help fix that problem, But that needs to be done pretty much up front. If you've got a site that you're going to be doing one of these build outs on, the power source, the sewage disposal, the clean water needs to be addressed up front. If you try to do it after the fact, invariably it will not do the job, and you're going to have long-term problems, health problems at the very least, but problems.
I have a question for you about this.
Yeah, go ahead.
Rob, what do
Yeah.
you think about oxidation, some kind of a portable oxidation system that could step in and oxidize the sewage? Do you think that would be preferable to the burning?
Better than burning. You're probably better off using the same kind of methodology we typically use for when we're building a house that isn't connected to a sewer, where we use a biological material to break down the sewage and make sure that it better processes through the earth and doesn't create the pollution. It seems to be a bit more a little lower tech. What?
You mean like a probiotic?
Probiotic, like using enzymes,
Yeah.
and use that to break down. I believe Bill's methodology is largely enzyme based, I still remember you use the bathroom and then you drink the water. I'm not sure I would have done that right next to him, but he made a point. It
did make a point.
It did make a point, and many trusted the technology, but it's a little bit more sustainable when you start dropping in complex technology into an area that may be depressed. You have a problem with theft of the technology. You have a problem with maintaining it, and so the more that you can do, that's probably a bit lower tech that does the job, and this biological approach to the problem, once it's in place, tends to be low tech. Now you do have to make sure that people aren't putting the wrong stuff down the toilet. Because you can destroy that entire ecosystem if people are pouring oil down it or doing things like that, which can happen. So the folks need to be trained not to destroy the ecosystem that you built. But however you get there, you do need to think hard and fast about how you're going to deal with sewage and waste. Otherwise, you're just going to have another problem you're going to have to deal with, and the site may become unlivable for other reasons.
Do you know anybody that's scaling the toilets, including Bill Gates? Do you have an update on that?
I don't. We probably look it up. Bill's efforts relatively well funded, and he tends to go for large scale trials. So there's no doubt in my mind there's some large scale trials going on. I didn't look at that in preparation for this call.
Right. Yeah. So when I'm on Facebook, I met yesterday a young teacher. She's looking for benches for her school, and she disclosed to me that she's a refugee. She's in a refugee camp and she's looking for benches. So obviously this teacher is hunkered down for somewhat long term if she's planning for school benches for her kids. So more attention to what they're doing is very, very important, because we have a lot of, intelligent beings being trapped in these areas without a lot of support, and, that's pretty tough for them. So one of the things we're looking at with our offsetting pricing is charging a premium based on income levels so that we can take the load off the low income people who already have a low carbon footprint, but basically progressively bill higher income people a little bit to cover for some of these people that aren't capable, so that they're included and covered. And
sadly, that stuff that doesn't work, rarely works. The reason it rarely works is that the high income people tend to get a much larger vote than the low income people, and invariably they pull the rug out from underneath these efforts. So that's what happens here. The folks with a lot of money have a lot of influence, and they tend to be able to effectively prevent this. That's why I think 61 people own 51% of the world's wealth, which is just insane.
Yeah.
But fixing that would be
the economic model that we're currently operating under. And the externalities that these people are suffering are not regarded, because even in advanced Western society, the externalities are often ignored, which is what happened with the fossil fuel consequences for climate change in the first place.
Yeah.
Yeah.
Yeah, it's the dealing with the politics of this stuff is ugly. But back to the issue with regard to a tent city for immigrants. One of the big issues with regard to tent cities that is not that so much the material that's used, is that they tend to have to go up really fast, and nobody knows how long they're going to last. And so you have an event, Ukraine gets invaded. Now you have millions of people you have to house, and you have to house them within 24 hours. You're going to start seeing large scale deaths. And tents do have that advantage. They can be stored small, and they can go up fast. All the other disadvantages as far as being lasting and the rest of it are offset by the fact that speed becomes the overarching part of this. Now, to solve that with a better structured approach, you could use heavy lift dirigibles, which we're looking at. So you build the structures, you have them much like we warehouse old military equipment, an area standing by, and then when an event like this happens, you bring over a heavy lift, and the heavy lift picks up the structure and takes it to the location where you need it, and there you only have transport time. And the heavy, does have a weather requirement. Heavy lift dirigibles, you're not flying them through heavy weather. You've got to have a wind speed of probably under 30 miles per hour legitimately for transport, and certainly for placement. It's going to be really hard to keep up an airship steady and anything over 30 miles per hour. But it does provide an opportunity for a different kind of approach and perhaps a better structure, because with a pre-built large-scale structure that you assemble in places, you could build the water storage, the sewage capabilities into the structure, a power generation you could build into the structure before it's all delivered, and then it's delivered intact, and then you're just hooking the different structures up, the generating stations up, the sewage stations up, and you're still doing it relatively quick, and it can stay in place for as long as you need it to stay. More important, you've got security built in because you've got hard walls instead of tent walls, so you're not putting up fences, and fences tend to be problematic. And you can have better containment, because often when you're putting up these big tent cities, you've got criminals, you've got different groups that don't like each other, and you're throwing them into close proximity, and that often makes rape likely, abuse, murder. You've got major crimes that are almost immediately appearing, theft, fraud. They're almost immediately occurring within the group, and are very hard to contain and control. Where if you're putting in place an existing, the structure's done, you can do the pre-planning to begin with. You can build the structure in a way that you can, if you've got a problem with people fighting or groups moving hostily against each other, you can secure those groups, and physically keep them apart until you can put people in place to calm things down or whatever. And you can even use some of the other methodologies of sound management. Some of the things that the people complain about in these facilities is, you've got some groups that need to, pray at certain times of the day. Other groups need to sleep at certain times of the day. A lot of aggravation with regard to noise, because tents don't contain noise at all. Crying babies alone could be enough to push a lot of people over the edge. So with a pre-built structure and using heavy lift, you could have something that's much closer to that arcology that I mentioned, but actually have it be portable and come to someplace to be used. And then when it's done being used, heavy lift comes back in, lifts it back up, and that land is now usable again. You don't have to go back in and try to deal with the bio waste, the pollution, and the other stuff that's left behind after a tent city, which makes it more like a dump in terms of how you build upon it going forward. And less like a piece of land that you might have used for farming or for build out a city or something like else. We don't talk about how these tent cities kind of destroy the environment they sit in, but they do. And if you use heavy lift and pre-built structures, you might be able to get away with that. And in fact, a lot of times when we're talking about, even with pre-constructed homes and 3D printed homes, when you're talking about a camp that was built ad hoc to deal with a specific time-defined problem. What do you do with these facilities once that thing is over? Once Ukraine's over and people go back to Ukraine, I'm not sure anybody's going to live in the community. The whole point was to build them and house them fast. It's not luxury living. This is still going to be hard living. So using these for something else could be problematic. Where if you could take the structure and you could move it, say if NATO were to invest in a facility to house refugees, which would make sense. If NATO ever does go to war, there will be refugees from whichever country is on the front line, and being able to build up a facility very rapidly that's both safe, securable. You could even build in automated defenses and defendable from the hostile force that you could deploy in France, you could deploy in England, you could deploy it in Finland, you could deploy it in Switzerland if you needed to. So they'll get over the Alps could be a problem. But it would give a level of flexibility and the ability to respond at a personal or at an individual citizen level that we currently don't have today.
Yeah, I have a question for you about robotics. Do you think advanced robotics could assist in the logistical aspects of getting facilities up and running quickly, or helping
it
to
could.
maintain?
You certainly could, but remember, the more advanced the technology, the higher the requirement for service and support. And so often when you're trying to put these things in very quickly, it's that we're seeing that right now with regard to Ukraine. There's a lot of resistance to giving them F-16s because they don't have the support structure to handle them. Same thing that went with regard to the M1A1 tanks. They require a lot of logistics. That they are rolling computers, and without the logistics in place, I mean, and they'll go through 300 gallons of jet fuel in a day. So without that infrastructure to supply that technology, you would have an inordinate amount of failures and support problems. So while robotics would make a certain amount of sense, for instance, going into an area that was hit by an earthquake, because the rest of the structure would be in place, it may not work in terms of providing a remedy for war-based a situation because the infrastructure to support the robotics may not exist. But it certainly could be a solution. And particularly we talked about large scale robotics. In other words, the kind of things that Caterpillar works on. We're talking about large scale robotic equipment, not a lot of little robots where your logistics and particularly your support issues could be exorbitant, but large scale robotics where the support issues may not be. So you might only need 4 robotic cranes or something. That might be doable because you could ship them out with the support teams to support them, much like Cisco does when they send a team in to restore communications. They don't just send the technology; they send the technology along with the team to support it. And since we're just talking about building a structure, not about building an army, the number of teams could be containable. So with that caveat, robotics could be, particularly if you design the robotics for a hostile environment, much like we do for Mars. I mean, we're sending robots to Mars, no support, and they're lasting for years. So as long as we put the same kind of effort in the robots we're using here, or something close to that, I think it can be doable. But we have to think through the logistics and the support for the robots to make sure that the teams are in place that can handle any problems that might otherwise occur. And if that's done, robots are a great force multiplier. And if a robot's injured or hurt during the process, it's less of a concern than if a team of laborers are. And particularly we're talking about, and here if we look at the earthquake recovery stuff, that's where robots really could come into play. Because it's a very dangerous environment, or a mine collapse or something like that. Incredibly dangerous environment. Very, very likely that the rescuers are going to get killed as part of the process. Their robots could play a huge role, both by being able to handle things people can't handle in terms of weight, and number 2, if there is a collapse and the robot's damaged, at least you didn't lose 20 people.
That's right. And, these temporary emergency crisis structures that are put up, once the crisis management teams have determined that it's going to be a little longer term, they could actually have a status change program and logistical plan in place to step it up to a longer term with supports in place. Now, what they usually do, I think, is they scale up the food supply, they scale up the sanitation, they do what they can around the temporary structures. But even if they had, on a second stage area for the refugees, the common structures, just the common structures hardened beyond the tent stage, so that people living in tents could at least transition over to something a little bit more modern. So that's some thinking I have there on that.
Yeah, you could do a phased approach. In other words, go fast tents first, and then rotate to one of the longer term, less rapid than tents, but more rapid than traditional building structures over time, and certainly use it at the same time to build some of these common areas. The thing with regard to tents, when you do have a disaster, people have to evacuate the tents and go someplace else, and building that someplace else that's much more robust, someplace for them to gather during an emergency that's safe and protected, could also be done. Leaving the tents in place, but building some centralized structures that were protected and far more robust to survive a weather event, survive a military event, better survive, I guess, attacks by space aliens, because that's what we're doing right now. But in any case, the better able to solve the holistic problem that you're trying to address, rather than having one large tent for a place for them to aggregate, which would not be effective if you had a hurricane come in, for instance, because you're running to some place it's going to be safer than where you were. Or if you built a structure, it could survive it.
Some of the places that they choose for the tent structures are not suitable for long term, and they may not necessarily know that going in, and more assessment being done on where a slightly more permanent situation for that group of people needs to be embedded in the logistical plan, if at all possible. I realize with some of these island states that get the earthquakes and the recent earthquakes we've had in Iraq and so on, people, these are their home territories, but for the climate related events, the randomness of where weather hits, I think as we transition and the Arctic breaks down with the Rossby waves throwing off this weather whiplash that everybody's having, there are some patterns that are emerging, but they're probably going to change yet again. So it's difficult.
Well, a lot of those island states are going underwater. And figuring out a long-term solution for that, either building those islands up or finding a way to wall them in and keep the water out, or something else, short of relocating the population, which is probably what's going to happen now. That could make a huge difference. And here, 3D printing could play a pretty decent role if you were talking about either building up. Or building a structure around the island that would help prevent the intrusion of the water. Granted, you can only go so high because the water will come underneath walls if it gets high enough. But it would allow a relatively rapid way to mitigate something that does require a much more robust structure, because you're not going to put up fences or any light structure to hold out water. It's too heavy. And their 3D printing provides a way to rapidly build a structure that can withstand, to a certain degree, water. And depending how you lay the foundation, you probably have to trench and then lay it below ground. But you could build a relatively decent wall to hold off at least occasional high water reasonably quickly with 3D printing.
Are there with
weeks
the 3D,
as opposed to years?
I have a question about with the 3D printing, Rob. Yeah. Do they have sort of modified concepts around the good old sandbag approach, which is often a temporary and a very successful and can actually end up being quite long term? So are they applying some of the sandbagging types of principles for the management of floodwaters?
The one thing, the sandbags work unless the water gets high enough, so it starts going on, finds a way underneath the sandbag. So the same thing with walls. It's the same exposure, but with the walls that you trench, at least you provide a better water barrier than sandbags. The advantage of sandbags is they go up really fast. They just as fast as you can throw the things down. 3D printing can go up as fast, if not faster. It doesn't. You're basically just pumping the material. But you could drop sandbags when you already have water intrusion. You got to get the 3D printing at least high enough so the water isn't intermixing with the cement for it to work. So you do have a time element with 3D printing. You need to start the process before the water starts moving. Otherwise, you're going to have a problem with the cement setting. Now, you can get concrete that sets underwater. I haven't seen it used with 3D printing. But there's nothing that says it couldn't be. So there is a possibility using a different mix. You could also solve a problem where you already had water intrusion. But right now it would be best if the wall was set when you were anticipating the problem, not when the problem had already occurred. And nothing says you couldn't use a combination of sandbags and 3D printing. Sandbags to dry out the initial area, then 3D printing to make a more permanent solution. And then you'd remove the sandbags and continue on that way. So make it a phased approach.
Yeah.
And you could also use manufactured walls, drop-in manufactured walls first to stop the initial water, then back them up with a 3D printed cement wall that would provide structure for when the water goes higher. You could do that as well. So nothing says you have to use any of these methodologies in isolation. There's an argument to be said that you could use them together. So, for instance, using 3D printing to set the foundations and baseline, then using a manufactured home to lay over and install. Because the advantage of a manufactured home over 3D printed home is it can come in complete. It can come in even with the appliances in place and dropped in place. For a 3D printed home, it comes in. You're basically just talking about the wall and roof. You still have to do the electrical. You still have to do the plumbing. You're going to put in any appliances, countertops, cabinetry, all the rest of it. With manufactured home, that can all be pre-done. And you can drop them. The Blue Homes is a good example of a very high level, very robust manufactured home. You build the foundation, it shows up on a semi, and it's assembled in something like 8 hours. And when they're done, it's done. Your power's in place, your plumbing's in place, your appliances are in place. You can move in, and with now much more build time in the factory. But the site build time is incredibly short, and even shorter than 3D printed homes. And so you could use 3D printing to set the foundation first, and then pull the electrical and whatever you're going to do with regard to waste management and water, and then you drop in the manufactured home, and boom, you got a house. Yeah. So but it does mean if you have a catastrophe or whatever, you got to have a lot of these manufactured homes done and ready to ship out, and you have to have an ability to get them there. And often when you have an event, your roads are pretty much crap, and so getting a manufactured home without using something like heavy lift aircraft could be problematic because you may not be able to get a semi to the location, and you might not be able to get a crane to the location, and you're going to need a crane to unload the semi. So in terms of disaster recovery, that's where we go back to this idea of we really need to revisit, and clearly a number of companies are revisiting lighter than air heavy lift as a way to get facilities into areas where you really can't use trucks or land-based transport, and build something very rapidly.
So yeah, something like a big drone, a giant drone vehicle that could do a heavy lift would be something really fantastic to think about for dropping in, the manufactured homes. And the other thing I think about, because I actually have resided in a manufactured home, is I have a question for you about the recycling issues for when they do have their end of life, because either through damage from additional storm activity or vandalism or, flooding or whatever, the manufactured home, it can suffer the prospect of becoming unlivable at some point, either, due to all of that or due to age. So what about the recycling? Is there advances in that area that you know about?
Well, their advantage, the manufactured home was assembled in parts, and so and invariably it means it can be deassembled in parts, and where a regular home tends to be built as a whole structure, and so when they deassemble it, it's not like they take it apart in parts and separate all the stuff. They tend to throw it all to the dump. I mean, it gets bulldozed over and all the stuff gets hauled off. It's not easy to deconstruct. You could do it, but it'd be very labor intensive. Where a manufactured home, you could do one of two things. You put it back on a trailer, haul it someplace, and have it deconstructed in a factory. The same kind of thing we do for electronic equipment today. You could do that with a manufactured home. It was trailered in. It could be trailered out.
And cars, cars do it. Yeah.
Yeah, and the question is, would people tolerate the cost of doing it? And that's often the case we have with electronics today. Is we can do it, but it's often far cheaper just to throw it into a landfill than to take it apart. Now, you could put in place rules that specify that when the home's built, it can be easily deconstructed. The concept Luna that Dell just showcased this last year at CES as a way to build laptop computers is a case in point. It was a laptop computer that could be assembled on demand using a computer and disassembled on demand using a robot, and then those parts can can either be reused or that they can be sent to specialized recycling plants in small form where the precious metals can be pulled off and all the rest. So much more sustainable approach.
Yeah.
But the product had to be designed to allow that to happen, and for the most part, these housing constructs are designed to keep the cost. I mean, the predominant drivers have a low enough sale price that somebody would buy it. And if you increase that sales price because you're building in these other items, either the government's going to have to provide subsidies, rules so that they don't face competitive pressure. Because if a house that can be taken down and deconstructed is $150,000 more than a house that is, sadly, most of our buyers would probably buy the cheaper house and say deconstruction is somebody else's problem. But if they can make it equal or close to equal, then a buyer would take it. And same thing if you're going to an agency that's trying to build out something very fast to take care of immigrants, they're held to budgetary constraints. And so making those budgetary constraints go away so the right decision is made should be part of the process.
Absolutely. That's fantastic information. Thanks, Rob.
Hey, my pleasure. Sharif, was something else you wanted us to chat about on this? It's because I'm running out of.
Actually, housing is a very big problem for emerging economy. I'm just thinking that how it can be price effective for our emerging economy, because pricing is major factor for emerging economy. Do you have any advice or pricing strategy?
Government subsidies can play a major role here. Because the construction process does require a certain amount of upfront investment. I mean, 3D printed homes are arguably quite a bit cheaper to build than regular homes, but you still have to buy the 3D printer and you have to train people on how to use it. And so getting that foundational part in place is something where a government would have a significant play, much like government would invest in any technology that they wish to advance. Government would need to step in and provide incentives to provide this and assurances that once done, what's been created will be utilized. You often have to fight a number of unfortunate fights when you're coming up with an artificial technology. One is you may have unions that object to the use of this technology. A carpenter union, for instance, may have real problems with a 3D printed house that doesn't require carpenters. Same thing with a manufactured home. If you've got a carpenter union that's in the region, you bring out a manufactured home, you don't need carpenters. I mean, you might use a couple for finish work, but the amount of people that you're going to employ during the actual placement of the homes is low, and that's part of the benefit, is because you can build these things fast with far fewer people. But if you're part of a group that wants to stay employed, then you might have a problem with things that go in fast using a small group of people. I remember I reviewed a smart building in Toronto that Cisco built, and they brought in, and the only thing that they brought in was Power Ethernet (PoE), and it made the assembly, the electrical component of the building go in very quickly because it was single cable, and that single cable provided both data and power, and allowed every single room to be smart. So lights came on and off with regard to when people were in and out. The savings were phenomenal, not only in build cost, but in electrical charges were significant. And yet the electrical union went to war with this because technicians installed PoE, electricians installed regular electrical wiring. And so the electricians had a major problem with this. Even though all the economics were very favorable for the building, they had to overcome the electricians union to actually get it in. So making sure that the people driving this don't have those kinds of headwinds often would make a huge difference. And if you're trying to create a small industry, that industry isn't going to be, at least initially, capable of fighting unions head to head. Won't be able to deal with both the violence. I've been involved in some of the biggest union uprisings. The Borax one is worth reading about. But in the end, making sure that the transition doesn't create unintended consequences and pressures and that could make it unsuccessful is also an important part of the overall process, because we're talking about a shift and we're talking about retraining people in order to do this, and that all has to be part of the process. So people, and you can understand, people don't want to see a threat to their livelihood, and so this has to be presented in a way that it's additive in most cases, and not a threat. And of course, if we're using it predominantly for something like refugees, the problem may not be very pronounced because there probably aren't any unions where you're going to put up the facilities. But on the other hand, if you're using it to replace the homes that have been leveled during an earthquake, there you're going to have significant issues with regard to the existing infrastructure regarding home and building and the building homes and making sure that that's mitigated becomes part of the process.
Yeah, the disruption that we're experiencing with the 3D printing and robotics and whatnot, it would be really nice if we could use the philosopher's stone to turn it into more benefit for people as a whole rather than just advanced society. You know, that's what I think. It would be great. And the disruption to the trades and the heavy manufacturing unions and this type of thing, they need to be brought on board with the whole concept of compassion for other people. So that's really
well. You just have to make sure you keep them whole. If you're running against a union, you probably should meet. I mean, what often happens is we get an initiative like this, we deal with the unions ad hoc. They freak out. So it would be where you've got the time. It would be better to see if you could deal with some of these problems before you enter, to see if there was a way to mitigate them by involving the unions in the underlying process. And it may very well be that for say a manufactured home, you build the manufacturing plant for the homes in the same geographical area, and then you employ the carpenters, the electricians, the plumbers in the manufacturing facility, with the argument that now you're inside, now you're salaried. Now you're salaried, you get benefits. You might get better benefits than you might have had with regard to working outside, but you're not working in sub-zero weather. You're in a climate controlled environment. You know, it's 105 outside, you're 75 inside. Weather event happens, you're inside and protected. You're not out of work if there's a major weather event, because you just go to the factory and you work in there as opposed to working outside. And so it better assures that your income is more consistent and that your working environment is a bit more favorable to people. You can do that, but those kinds of things should be handled, if at all possible, up front, so it mitigates the back end problems of folks freaking out because now they're being told they're going to be out of work and they don't know what they're going to do, and these new houses are going in and they won't be able to afford one. That's all stuff that can be that to a certain extent can be at least partially addressed before the effort is put forward.
Yeah, I just have one more point and then I'm going to have to get off the call. but the logistical capabilities of the trades and the unions needs to be a skill. Their skills transferring over into this area is very important and has a lot of high value. And also the other comment I was thinking that the manufactured homes, if they have central areas where they, in the developing nations, can actually do the recycling, it would be a welcome addition to where the garbage is being sent. So, for example, Canada sends its plastic overseas for quote unquote recycling to a developing nation. So, I mean,
It just gets
recycling,
dumped.
yeah, the recycling of the manufactured homes could be an economic program for a country that's enterprising and wants to take it on, once they, if they're in good enough shape to do that.
Sure, and you can do things like use plastics that are biodegradable, and in fact, you can create plastics that not only biodegrade, but they biodegrade into something that can be used as fertilizer. And then if you're shipping it to a third world nation and they're just dumping it on the ground, at least it's making that ground better as opposed to turning it into a toxic waste dump. So you can preserve the ecosystems, because those emerging countries get money for storing that plastic. But if you made that plastic more environmentally safe, then they not only get the money for storing the plastic, it doesn't destroy their country in the process. And
the other thing they're doing, excuse me, Rob, is they're storing carbon. A lot of these developing nations, and we have to let them protect and steward their natural carbon storage with their forests and everything.
Yeah. It's well, at least as long as you're doing it with forests, that's a good thing. If we're talking about taking the carbon and dumping it into wells, I'm not sure that's the greatest thing on the planet.
Yeah, well,
but it's certainly better than leaving it out and free. But it depends on the methodology that you're using.
For sure, we have a carbon dioxide crushing machine that can take captured CO2 and turn it back into oxygen, hydroxyl radicals, and it also makes tetrahedrally amorphous carbon, which is the hardest known carbon. And what we think we'll try to do is get a laser system that can sinter it into complex objects, and other people have already started.
These are for building.
Yeah, so for building materials and all kinds of wear objects. Yeah.
Yeah, I've seen that as well, because the creation of concrete and cement, it does use resources, and it stays in place for a long period of time. And in theory, if you built it this way, you could recycle it. Not that that's all that developed at the moment, but you're building. You're not just taking the stuff and pumping it into a mine or putting it someplace where it could eventually escape. You're putting it into a structure, and if you're doing it properly, that structure could remain in place for a long time, and those materials could be reused, so the carbon doesn't remerge. That would be a great way to approach the carbon capture. Of course, we get people to stop producing the damn carbon in the first place. That would be better. But one of the things, carbon capture, that would be a great way to approach it.
Yeah, one of the things we're watching is, as the technology and the fossil fuel and the heavy industry is mothballed that is producing CO2, because there's going to be some shut down, some that will do CO2 capture. And the location of those places is not decided yet, but not fully. So once that's decided, then we'll go in and offer the CO2 crusher as an intercept for the CO2.
Right.
Yeah.
That'd be cool. And don't forget, you could undoubtedly use that stuff in the mix for manufactured home cement. And it might result in a much more solid structure in the end.
Yeah, well, we're looking at, basically scaling it up enough that it only costs about $5 a pound. So that's
of course it's heavy, so and intense.
Yeah.
But yeah, cool.
Yeah.
Thank you. This is a really great discussions, and we have to go for the concluding remarks for today's session. Madam Viva, what's your concluding remarks?
I think that there's going to be a lot of positive change in the disaster management world by being forced into it with climate collapse. It's unfortunate, but that is the positive side to it. It's going to force people to evolve their techniques and their tactics and their planning. And I think it's happening right as we speak. So, I wish all those people very, very good luck and great success in what they're doing. And with what I'm doing with the hydroxyl dispersal to calm the climate and, get a global oxidation event happening with a lot of positive benefits around biodiversity, plant diversity, and mineral diversity. I think that, humanity is headed for a positive place in the future.
Excellent. Mr. Rob, what's your thoughts for today?
Well, we've got a lot of technological solutions to apply to the underlying problem of homes and providing homes for those that are homeless, whether they're homeless for economic conditions, homeless because of military issues, homeless because of weather issues. We have the capability to provide homes at scale. We have manufactured homes, 3D printed homes. We have the concept of our ecologies to create contained environments that are much more sustainable, because the one aspect about an ecology is by its nature, it's designed to be sustainable, to create what potentially is a circular economy and keep the waste it creates contained within the system that created it. And none of these are mutually exclusive. That they can be used together and in concert, depending on the needs that exist at the time and the economics and materials that are available. But the requirement, or what needs to be done, is it needs to be approached strategically. We need to anticipate not only what the needs are today, but what the needs are going to be in the future while the structure is in place, and also anticipate other aspects, the collateral damage that may occur by the choices we make, and of course the need to eventually disassemble and recycle the structures that we create. So a holistic plan would include all those elements, and might even include heavy lift as well, in a way to get, for instance, manufactured facilities up quickly. And you could certainly see a situation where a refugee camp might start off with tents, move to 3D printed structures, immediately have common areas that are heavy lifted in, and provided cafeteria facilities, areas for washing, clean water, and sewage. You might not put those in the living facilities at all. You might just centralize them, which is what we often did when we went to summer camp, or if you go to the military. In the military, you don't have facilities. Often you don't have facilities in every barracks. You have central facilities that the people go to, and those central facilities could be delivered using heavy lift relatively quickly, and in some cases they are. In what looks like large containers, but you could do it even larger with a lighter than air heavy lift, and actually bring in complete buildings, including the defensive structures that you might need to control the population, as well as keep hostile forces from attacking the complex, which in a military situation would be a requirement. I mean, if you think about it, the ideal place to have refugees would be in Ukraine. But the problem with that is you need to defend the facility, otherwise it would become a significant target of opportunity. But you could, with pre-built heavy lift, have capabilities of installing a facility that had all of those capabilities, and you'd be better able to defend a discrete area with anti-missile systems, things like phalanx, which are very effective against missiles, and could be installed with regard to the facility, and without the downsides, because the downsides of phalanx, of course, is what happens with those rounds when they miss the missile. So that can be designed in, and that keeps the people in the country where they are without putting the burden on adjoining countries which may not be set up to handle it. And now you just send in funding, provide the capability. And it stays contained within the country, and it leaves people closer to their families as well. You've got soldiers that are fighting that war; they certainly would want to be closer to their wives and children, if those wives and children can be maintained as safe. We've got a complex set of tools, a relatively simple problem, and the goal is to make sure we optimize against the problem with that tool set. And one thing we didn't talk about was artificial intelligence. And the neat thing about artificial intelligence and concepts like the metaverse is we can model all of this. When we have a problem, we can fully model the situation, and then against that model, we can trial the different solutions and see what works best. So when we finally roll out the solution on location, it has been optimized for the problems we had, and we don't have to do a lot of rebuilding or restructuring because we didn't anticipate some things we probably should have anticipated before going in because we were in such a rush. And the nice thing about these simulations is they can be brought up in minutes. So it doesn't add a ton of time to the overall process, and could subtract a ton of time, which is often going towards undoing mistaken decisions during the initial phases, and avoid those mistakes in the first place. So we are unprecedentedly capable of solving problems like this, but to do so, we have to approach them very differently, very, very strategically, and use the tools we have to both analyze the problem and to derive the most appropriate solution to that problem across a number of technologies and capabilities. And that's it for my closing remarks. And hopefully Sharif will come back and be able to close this thing down. Thanks, Sharif. I'm done.
Sharif?
Hello, Sharif.
Okay. Sharif, are you there?
Yes. Thank you. Thank you. Yes. Can you hear me?
Yeah,
Just
you're going in
barely.
and out, though, so you might want to shut this
Can you
down
hear me?
before you crash again.
Okay. Thank you. Can you hear me?
Yeah.
Yeah, can hear you now.
Okay. Okay. Thank you. Bye-bye and take care.